Zeroth level approximation, the whole thought experiment. All right, you got a cat in a box. I personally like cats, so I prefer Professor Carroll. He uses quote unquote sleeping gas, the original one. They use like some type of poison gas, and it's like, all right, what are the chances of this radioactive element decaying, triggering the release of this gas? In this case, we'll say sleeping gas. Is the cat asleep or awake on the inside? And the whole concept is, well, until you check the box and you do a quote unquote measurement, whatever that may or may not be, we don't know. There is some uncertainty, if you would, here. And it allowed modern internet to have so many different memes, and it's apparently, I think one of Schrodinger's relatives at one point was like, I just don't think you like cats. So, hey, to each their own. But I digress. Okay. So as we can see here, this is from Nature. So Schrodinger's cat just got a little bit fatter. Physicists have created the largest ever superposition, a quantum state in which an object exists in a haze of possible locations at once. Ooh. And again, this is the generalized, what many people interpret as what's going on. Quantum weirdness. Certain folks like Professor Barondus from Harvard and his indivisible stochastic processes would probably say that no, there's actual stuff going on, and you could explain it if we take the past into consideration. That resonates with me. Also, I figured this was topical, and I hadn't seen Anton do a thing on this yet, so I'm sure he will. And it's not like, hey, blatant. If other folks are talking about it and I haven't seen any other videos on it, it's probably a good time to do it. Oh my God, trying to play the news. Who's ever done that? But I digress. Okay. So basically, a team based in the University of Vienna, they basically put like 7,000 atoms of sodium metal. So basically, it's about 8 nanometers. Wait, what the? 8 nanometers? What is that? From alpha, 8 atom. All right. So, yeah, that's roughly about a billion times smaller than like our scale. So if our scale's about a meter-ish, so basically your standard step or something, or basically you take the football field for the big game that's coming up, you divide it by 100. Yeah, it's about 10 billion times smaller than that. It's 10 to the 9's got like 9 zeros in it. Okay. So, yes, yes. Yeah, microscopic stuff and things, that's of the magnitude of stuff. All right. All right, and all right. So, and they're spacing them about 133 nanometers apart. All right, so that'll go from like a billion to like 100 million. No, only about a million. Only a million times smaller because it's that's a single magnitude. This has 3 digits in it. All right. So rather than shoot the experimental setup like a billiard ball, each chunky cluster behaves like a wave, spreading out into a superposition of spatially distinct paths and then interfering to form a pattern researchers could detect.